Hi, in this notebook I'm gonna talk about transfer learning. So let's get started. Well, suppose that you are a computer vision engineer in your company and the business manager call you for a talk about a business opportunity. And in this talk, you conclude that a good solution could be develop a deep learning application. The business manager say, okay, no problem, but you have 10 days to provide a demo application so we can do a presentation to the director board. Okay. After that, you start thinking in the solution and you conclude that you are facing some problems. For example, you don't have budget. Okay. Another problem, you don't have enough time to train your model because remember, um, sometimes train a model will waste weeks or even months to train this model. So we have only 10 days. Okay. Another problem, if no money and no time, we can think that you are not able to collect enough data to train your model. Maybe we will need millions of samples to train your model. Another problem that you can face that you don't have a good hardware. I mean, multiple GPUs to train your model. And we can list other issues or other problems that we can face. So how can we manage this scenario? Okay, well, instead of training a model from scratch, wasting time, wasting money, lots of data sets, lots of samples, weeks and even months to train this model. What we can do is just download from the internet a pre-trained model. Um, that what does that mean? It means that a training model is a model that was already trained by someone, for example, researchers or other professionals, using lots of data, money, multiple GPUs that uh, um, could got the weights that can provide high accuracy for your task. Okay, so there are open source models uh, called pre-trained model, as I already said, that can be downloaded from the internet and you can use to provide the solution for your task. Okay, so how can we do that? Going ahead in this item 2, I will uh, I will describe a real example here that I faced this some time ago. For example, I had participation in the Lockheed Martin challenge, where I had to provide in short time, like in this example, an object detection algorithm to be used in drone. Um, I mean, um, while the drone is flying, it must fly through some gates used in drone, drone races. And in this case, um, I have I need to have an algorithm to detect this gate and pass the information to the control system inside the drone, and this system will guide the drone to fly through the gate. So you can see here in this picture the gate in the drone race environment, and note that the drone must fly through this gate that is this area that is defined by these four lines here. Okay, this is square picture here, and this is what the algorithm must do in this case. Okay, in this case, I had to use 2,000 images. 2,000 images is a few set of images, and split this data set in train and validation. Okay, so at final I had 1,000 images for training and 1,000 images for validation data set. Okay, that was one problem that I had to solve, and in this case I'm using this example in this notebook. Okay, going ahead, let's see how the transfer learning works. Here in this picture, you can see that we can load the pre-trained network, the pre-trained model in this case, and we select the last layers. You can see here in this picture, the last layers in this pre-trained model. Okay, then we replace the last layers by new layers. And these new layers will be responsible to learn the new features regarding to our new task. Okay, and remember here in this image that the other layers are responsible to learn low level features of the samples that were used to train this model. In this case, we can list some of them, like edges, blobs, colors, shapes, and so on. So this pre-trained model was trained using, for example, millions of images. Okay, so going ahead, what we have here in this other picture is that the training process, and in this training process you can see that the new layers are being trained in the new features. We keep the old layers, okay, and retrain the new layers in the new features. Okay, note that here we are using few images in this process. After that, we go to prediction process, where we use this new model to predict our samples and provide the results that we are looking for. Okay, so in this image, item 2, you can see how the transfer learning works using a pre-trained network. Going ahead, note that in this example, I used the YOLO model that I could download from the internet and use this pre-trained model in this project. Okay, if you are interested, you can download the YOLO model pre-trained from this link. Okay, sorry. Okay, we can also create a to-do list about what we need to do to train this model. So, what we have here, in this case, because we are using the YOLO model, we need to use the VOC dataset. I'm using the VOC dataset. Okay, another item, we need to pre-process the label file, removing any undesired values in this data set. For example, empty labels. Also, another item, we need to link the labels to image files. Okay. Another item, we need to create the directory structure that will keep the files. In this case, the training and validation data sets, and also the test data set. Okay, that in this case the test don't need to have much images. It's continue here. The other item that we have is we need to update the config file where it will contain the variable values to be used by the training model. And another item in this to-do list is download the pre-trained model to use in this project. In this case, we are using the IOLO model. And another item, then create the next step, create the model here. Then the next step, after create the model, load the weights. Remember, the weights that we already downloaded from the internet. So the next step is train the model, save the training model, so we can use this training model in others time, the next time that we want to process the inference of our sample. When we need to others inference process for ours to test our samples. Okay, and finally here make prediction of our samples. So going ahead, what we have here, housekeeping, which means loading this notebook some packages, like for example Keras that we are using over TensorFlow that we are using as a backend, and other packages like for example NumPy and others packages to be used in this notebook. So going ahead, another step is to configure the variables. Remember, we have some images, image files. So here we define the image file, the size of the image file, the grid size to be used by YOLO model, the number of boxes to be used by the YOLO model, and other variables to be used in this training process. Remember that here we are using a pre-trained model. Now we define directory structure as we stated before, and here we have the train directory with images and annotations. Then we make the annotations parsing, and we define here a normalization function that will normalize our images, and then we load, we create the batch files for training, and also going ahead we define our directory structure for validation, and repeat the same process for the validation, create the batch files, and going ahead we process the sanity, which means we test if we are loading the images correctly, and you can see here that we have the images loaded correctly from the directories. And now we build our model. Okay, we build our model. Before here, we just define a function that will organize our model, And here is the model itself. Okay, the convolution layers for using this model. And at the final, what we have, we print, okay, we display the summary of this model that we can see here, the input image size here, the beginning of this summary, and going ahead at the final of this print, what we have is the output, the grid size, five boxes, and the number of classes that we want to classify. In this case, one class. Okay, going ahead, what we do here is to load. Remember, we are using a pre-trained model, so here we define where is the pre-trained model, and we use this function to load the weights. And now we recreate the last layers for this new model. These new layers will be retrained for our new task. And here, still for these new layers, we randomize the weights to avoid issues during the training process. So we perform the training process here, and remember that we need to provide a custom function that is here, our loss function. Sorry, not custom function. Our loss function, our custom loss function that will be used during the training process. And just another two other comments. We have here two functions that are the early stopping and model checking that will save our best model when the training process is stopped by the early stopping function. In this case, the current weights are saved to disk, so we can use these weights again in others process, inference process. Here is the load weights if necessary. In this case, in the first training process, we can comment out this line, because in the training process we already have the training model already loaded into memory. Okay, so going ahead, we define here some log files used for debugging, and in this cell we have the training process itself. The training process itself for our model. And you can see here in this cell that we got nearly, let's see, 5 epochs. So here, how many epochs? 8 epochs from, if I'm not wrong, 100 epochs was the final value for number of epochs. So you see that with 8 epochs, it was enough to train our model, or at least to reach the best loss value of our function, loss function. And another information is that this training process took about 3 hours. Remember that what I said, that training a model might take weeks or even months. Even the Ayula model, okay, that used to be a model that it takes a long time trained. But in this case, because I'm using a pre-trained model, it took only 3 hours to reach the best loss value function. And here we are just testing our model, okay, in these two left cells, and we can see here that we use test image using image number 30 from the test directory, and we load the pre-trained model and process this image, and what we have, voila! You can see here that the model could correctly detect the gauge and draw square around the gauge, signalizing that the gauge is here inside this square. And that's it. You could see that using a pre-trained model, we can redefine the functionality of this model. That's it. Thank you for watching.